I'm Ron McCulloch, the FTIR product manager with AMP Cherokee. With us is Stack Tester Joe and our mini methanol plant. Joe's going to help us with some spiking demonstration later. Today we're talking about validation spiking with FTIR stack testing. It's a key factor in having a robust data set, or if you will, valid data. So I'll give you an overview, but it's up to you to read the methods and follow the requirements. The basis of the spiking is methods 320 and 301. Methods 321 and ASTM D6348 accomplish similar ends as well. So the big idea is that you demonstrate that you're validly transporting and measuring analytes all the way from the probe to the analyzer and quantifying the measurement bias of the entire system. So briefly, we measure the unspiked or native analyte concentration that's in the stack, and then we add or spike a known amount of analyte to that sample stream. You calculate the expected concentration, you compare measured to expected concentration, and the average of that measured to expected needs to be between 70 and 130%. So you're replacing conceptually 10% of the sample volume with a spiking standard, ideally of higher concentration. So if there's 5 liters per minute sample flow through your entire system, you're adding 0.5 liters per minute of your spiking standard. And that yields a weighted average concentration that's greater than the native. When and how often do you do it? Every stack test. But you do it 12 replicates of unspiked and spiked, one time for each source type and condition. After that, you only do 3 replicates for each subsequent stack test. How do you know how much spike you're adding? Usually there's a tracer in your spiking standard, typically sulfur hexafluoride, SF6. It's inert, it's easy to measure, and generally it's not already in your stack gas. So let's take the example of methanol at 15 parts per million in the stack, and a spiking standard cylinder that has 50 parts per million of methanol and 5 parts per million SF6 tracer. Method 320 requires that you add no more than 10% of your total sample flow as spike injection. So with a 5 ppm SF6 concentration in our standard, we'd be targeting 0.5 ppm of SF6 at our analyzer in our spiked stack gas. 0.5 ppm measured divided by 5 ppm in your standard cylinder gives you 0.1 or 10% spiking standard volume fraction. The remainder of that is 0.9 or 90% of that sample that's stack gas. Then your expected methanol concentration is 0.9 times that native 15 ppm plus 0.1 times the 50 that's in the spike standard cylinder, or 18.5 ppm. There are some non-tracer approaches to spiking that can work well. They are deviations from the method, so you would need to get approval of that in your protocol before you test. So let's see how it works in practice. Joe's going to help us again. We're using our control console. You can also use manual plumbing, rotometers, needle valves, things of that nature to control your spike flow. The first step, we directly measure the concentration of our spiking standard, and that's our reference value for the spike analyte, methanol in this case, and for the tracer, SF6. We're running scan averages of 15 scans, that's approximately 15 seconds. That's for the sake of time. Normally during stack testing, you're running 64 scan averages, or roughly 1 minute. So we need to determine our spike analyte response time by introducing the spike to the sample. Method 320 has you obtaining stable data for 5 minutes to ensure that you've gotten a correct response time. Now we adjust the spike flow as necessary to get no more than 10% injection rate. We wait for 2 times the response time and then take our spike value. Method 320 also requires no more than 5% difference between consecutive measurements. That's easy to determine at a glance using the average feature with the MKS software. It's also useful to record times and spectrum numbers for your spike data. Now we calculate our recovery. Here's an example of a 3-replicate 320 validation. Here's also an example of a 12-replicate 301 validation with bias calculations. So do your spiking. Do it every stack test. The methods require it. It quantifies your measurement bias. Thanks for listening and have a successful stack test.